Google just released a 26 billion parameter model that fits in 15 gigs of RAM. I'm running it right now with zero setup. Let me show you. But first, we need to discuss what is QAT. QAT stands for Quantization Aware Training. In a nutshell, in one sentence, QAT teaches a model to perform well at very low precision, so it runs faster and smaller while keeping most of its original intelligence. I'd just like to call out, though, that it is keeping most of its original intelligence. It will never be as good as the original, though. But still, for the new, smaller size, you still get so much more. For this demo, we are actually going to run that model on Unsloth Studio. Just open up PowerShell and run this command that you see on the screen. I already have it installed in my system, so I don't need to run it. But for you, you need to run it on PowerShell. Also, I have already downloaded that model on Unsloth Studio, but it's not really that hard to do. So as you can see on the screen, I am using there's only one variant for this. It's the UDQ4KXL variant, and it's already loaded. So now let's play around with it. Just gonna do one car wash test, and we'll go do some actual coding tests using Cloud Code. But since it's just loaded up on Start Studio, just want to show you how fast it is. So we'll just do a car wash test. The car wash is 50 meters from my home. I want to wash my car. Should I walk or drive there? And of course, you should drive because you need to wash your car, right? And just look at this, guys. It's 313 tokens per second. For my setup, I am using a 5090 with 32 gigs of VRAM. However, as per the documentation, you can use this on laptops with as small as 16 gigabytes, or I think I read somewhere even 15 gigabytes. So the cool thing about Unsloth Studio is once you install it on your local machine, it actually has an API. And you can, I think it's very similar to the OpenAI API format. And once the point of having an API is other stuff can connect to it, right? And for this demo, we're gonna use Cloud Code to connect to this Unsloth Studio instance. And it's running on port 8. I actually made this bat file, as you can see on the screen. And I'll actually be sharing this on my Git, and I'll put a link in the description, or maybe I'll put it as a comment in the video. But yes, I mentioned before, it's gonna look at port 88, right? So this is that over here. I'm highlighting it now. Yep, and you'll be able to access it on the Git anyway. Cool. So the beauty about having a bat file is instead of just running it from the console, running a command in the console, the command line, you can just double click. Yes, this is that bat file I was showing you earlier. So once you set it up on your system, you can just double click it and it will launch Cloud Code. Actually, let's do that now. Yep, so I just double click that bat file and it popped this terminal up for Cloud Code. So let's see if it's actually working. Hello. Okay, it responded. So I guess we can do some coding now. So right off the bat, let's start with something very brutal. Let's really push this model to the limits. I'm not sure, to be honest, if it can even do this. Make me a battle chess game using Electron, or put this in the C:/QAT underscore test folder. Create that folder. It does not exist. Yeah, I think for this video, we're just going to do this one test, and this should be enough to prove the prowess of this model. It's asking, what do you mean by battle chess? Which concept should I follow? I think we'll go with number 1. Standard chess plus abilities. Yeah, let's do that. So it actually came up with the plan. Battle chess game with Electron. And actually, I may have miscommunicated my intention earlier when it was asking some clarifying and probing questions. So let me fix that now. What I actually meant by battle chess is this. I remember way back years ago, I saw an old DOS game, PC game, wherein chess pieces were moving and fighting. For example, I use my knight to eat a pawn. There was some basic animations of the knight killing the pawn, but all the rules, chess rules, still apply. Just animations. Okay, cool. I think I was able to communicate what I really wanted, and I will leave Claude Code to it. Okay, guys, after around almost an hour and a half of back and forth, I'm not gonna lie, I'm not gonna sugarcoat it. This was not a one-shot generation. There were a lot of bugs and a lot of testing, but here we are. It's working now, and let's try it out. So yeah, the pawn is moving. So moment of truth. If I eat this pawn, I want to see some animations. Yeah, there were some animations for sure, but I think it's my fault. I wasn't able to articulate clearly what I wanted, but as per the requirements given to it, a battle chess game, it's working. It's yeah, it is working. Not just what I wanted, and again, that's on me. I wasn't able to clearly explain what I really wanted. Yeah, so actually, I'll just show you guys what I meant. Okay, so this is what I meant by battle chess. So it's a very, very old game. And this was even before Windows. This was on a disk operating system, aka DOS. Yeah, and looking back and how I just tried to describe the game on how it should be, I did a piss poor job. Yeah, but this is what I wanted. But again, it's not the model's fault. It's my requirements or the lack thereof.